Hello, and welcome to our live stream on the connection between sleep and mental health. It's part of our month-long effort to celebrate Mental Health Awareness Month, and we're so glad you've taken the time to join us live or via recording. Today, we hope to provide information to help you understand how our sleep habits, or lack thereof, are related to our mental health and vice versa. I'm Kara Gavin with the Michigan Medicine Department of Communication. We are so fortunate today to have three University of Michigan experts who can help us understand some of the latest science behind this topic and give practical tips for how to improve your sleep on your own or with help from a trained provider. All three of them are members of our medical school faculty. Dr. Ravi Alada is the director of the Michigan Neuroscience Institute and a longtime researcher on the circadian rhythms that drive sleep and wake cycles in animals and humans. And we have the co-directors of the Sleep and Circadian Research Laboratory in the U of M Department of Psychiatry, Helen Burgess and Todd Arnett. Dr. Burgess is a sleep and circadian researcher who tests circadian-based treatments in a variety of clinical disorders. And Dr. Arnett directs the Behavioral Sleep Medicine Program, which is our clinical program that treats people who have insomnia and other sleep disorders that often benefit from behavioral approaches. He also researches sleep in the context of substance use, such as alcohol and cannabis. Thanks all three of you for joining us, and thank you to the U of M Alumni Association for helping support and share this live stream. Before we start, a few housekeeping items. If you're watching this live, you can submit questions at any time, and we'll pick some to be asked during today's chat. Questions can be submitted at any time by commenting on this video on whatever platform you're watching on, but please note that your name or profile name will be visible to the others participating. If you prefer a more anonymous option, you can send a private message to us via the Facebook direct message function on facebook.com/Michigan Medicine. If you're watching this on the Alumni Association Facebook, please go over to the Michigan Medicine Facebook, please. We know that there may be many questions, so we'll likely combine some that are on the same topic. And please know that our experts cannot give specific advice for an individual situation that you might be facing. And if you can't stay for the whole chat or you want to share the recording with a friend, you'll be able to watch after the live stream ends through the Michigan Medicine YouTube channel. So, Dr. Lada, I'd like to start with you. And since you're a neuroscientist studying the very basic underpinnings of sleep, let's start with the basics. What's the circadian rhythm and how do we know it exists? And can you give us a taste of what your research suggests about why these rhythms are so important across species, why they might have a connection to mental health?
Thanks, Kara, and thanks for the opportunity to speak to this audience. Yeah, and I'll cover the basics. Hopefully, I won't put you to sleep in the process. But one of the basic understandings of sleep in virtually all organisms is what's called the two-process model, where there's essentially an internal 24-hour clock that kind of sustains wakefulness during the day and allows us to sleep at night, and a homeostatic regulation of sleep, which says if you've been asleep for a long time, you're going to be really tired. And we know that organisms on Earth have really evolved in the context of the fact that the Earth rotates every 24 hours. And so we have these internal clocks that allow us and virtually all life on Earth to really anticipate what's going to happen in our environment. So how do we know we see a clock? Well, one of the ways we can do that is if you were to go into a cave, and these were some experiments that were done many decades ago, you would still wake up and go to sleep about every 24 hours. So this is not driven by anything outside because your environment is constant. So it's your internal 24-hour clock is what's driving that sleep and wakefulness. And it's actually work actually done originally in fruit flies, which is actually the model system I work on, led to the understanding of the molecular basis of that circadian clock that was conserved all the way from the fruit fly all the way up to us humans, and led to the awarding of the Nobel Prize in 2017. We don't yet have a comparable understanding of the sleep part of that, not the circadian part, but the homeostatic part. And that's part of what's driving a lot of the research in my lab at Michigan.
Fantastic. And Dr. Burgess, you're also a neuroscientist studying circadian rhythms in humans. And can you talk about what you're studying and what you've found that might be helpful to people watching this live stream?
Yes, so in our lab, we are studying sleep and circadian rhythms in the context of different disorders. So, for example, the work we're doing currently, we're studying people with inflammatory bowel disorder, people with fibromyalgia, which is a chronic pain condition, people with PTSD, and also people with bipolar disorder. And I think the sort of common theme in this research is that we assess, first of all, the sort of baseline sleep and circadian disruption, and there usually definitely is some there. And then we introduce and test some pretty simple, usually non-drug treatments. So first of all, we try and stabilize people's sleep timing. We also look at light exposure, try and have people potentially get more morning light exposure. And these pretty simple methods, we find that we can see some improvement in sleep, definitely in mood, and people also report improvements in symptoms specifically related to the disorder that they have.
That's fascinating. And Dr. Arnett, you've been treating patients who have sleep disorders for years using techniques that are similar to the talk therapy that people hear about in treating depression or anxiety or other conditions. So, what is this approach to sleep care called, and what does it involve, and how well does it work?
Yeah, thanks, Kara, for the opportunity. So the technique you're talking about is called cognitive behavioral therapy for insomnia, or sometimes we call it CBTI for short. And it's a multi-component therapy that's made up of some behavioral strategies we teach people, really referring to what they do around sleep, the habits they have around sleep. And some of the techniques are cognitive in nature, meaning how people think about sleep or perhaps thoughts that keep them awake at nighttime. We teach them tools and strategies to manage those thoughts so they don't interfere with sleep. And relative to other psychotherapies, it's a briefer form of psychotherapy. So on average, we'll see people anywhere from about 4 to 8 times, with an average being about 6. So relative to other therapies, it's somewhat briefer. And in general, it's a pretty structured therapy. So patients would come to us. They'd meet us for 30 to 60 minutes over the course of a visit. We teach them these various techniques, and then they'd go and apply these techniques, practice them at home, do some homework, keep records, come back, report on how they did. We make adjustments, teach them a new technique, and it sort of iterates in that form over the course of those 4 to 8 sessions. It's now delivered in various formats. So we do it one-on-one in person, individual format. We might deliver it in a group format. We do group formats in our clinic a lot. It's a good way to learn about these strategies. And increasingly, it's delivered via the internet. There are a variety of different internet-delivered CBTs for insomnia that are out there and available, and actually have been pretty widely tested. And CBT for insomnia is now considered the first line therapy for chronic insomnia, even over medicines. Now, medicines are certainly more widely used for insomnia, but there's good evidence that CBT for insomnia should be the first line therapy. And in fact, it's recommended by various societies as preferred as the first line approach for people with chronic insomnia, meaning insomnia that's persistent over time. And there are several good, well-controlled studies that show it's effective not only in the short term, but in particular, one of its major benefits is that it has good long-term outcomes associated with it.
That's great. And actually, a follow on to that, are the clinic patients you're seeing, do many of them also have mental health diagnoses in addition to the chronic insomnia?
Yeah, absolutely. That would be in the main, the majority of patients don't just have insomnia, but most people we see have insomnia plus another health condition or a variety of health conditions, including mental health disorders, for sure.
Great. Thanks so much. Thank you all for that great introduction to what you do in your professional lives. Let's get into some more questions. One sort of introductory one I had is there a specific number of hours of sleep that a child or a teen or an adult should try to get each night? Or does it vary from person to person? And do you need less sleep maybe as you get older? Go ahead, Dr.
So
Burgess.
Well, I was definitely going to look at Todd for this one as well, but we certainly know there's recommendations out there, and for adults, currently the American Academy of Sleep Medicine recommends anywhere between 7 to 9 hours a night. Um, we know teens and younger children need more. Of course, it can be difficult to get our teenagers to sleep the 8 to 10 hours that's recommended for them. Um, but also, I was going to say that It has been said in the sleep field that there is a little bit of a sleep deprivation epidemic happening. There's statistics suggesting that about a third of American adults are sleeping 6 hours or less each night, which is really concerning. So I think there can definitely be individual differences for sure, but in general, we should be aiming for somewhere between 7 to 9 hours a night.
Thank you for that. And so I want to get a little bit more into the circadian rhythm aspect of this. And since we've talked about it, maybe I'll start with Dr. Alada with this one, and then others if you want to jump in. Is having a disrupted or disordered circadian rhythm itself a diagnosable condition? You know, if someone is working night shifts or their work shifts vary from week to week, are they at an increased risk of having a mental health concerns like depression or anxiety? You know, what help us understand about this dysregulation that can happen, even if you're just not getting enough sleep?
That's a great question. You know, there are many different ways of disrupting your circadian rhythm, and just to name a few that many of you may be familiar with. For example, if you were working the shift work, so you're basically working at night, and most of us like to be awake during the day, the misalignment between when you're awake and when your body says you want to be awake, obviously we can experience a lot of diseases as a consequence of that. One of the ways we can disrupt this is also travel. It's something that my lab has studied. For example, if you travel across time zones, and I normally I say multiple time zones, but you'll see in a second why I just say time zones. What happens is your circadian clock is very stable. It was never intended to fly on a jet. And so the consequence is when you fly from, say, Los Angeles to Detroit, your clock is still back in Los Angeles. It's still in Los Angeles time, at least for a while. It takes a while for it to catch up with you. And the resulting misalignment can lead to all sorts of kind of symptoms, sleep, disrupted sleep, GI issues. We actually did a study on Major League Baseball players and showed that pitchers give up more home runs when they're traveling east, even if they're traveling home. We don't normally think of traveling home as when you're jet lagged, but you can be. Another way this could happen is some people, and in fact, young adults who are in the kind of teenage years are actually biologically delayed in their phase. So it's almost like they have jet lag all the time. Some people call this social jet lag that you get on the weekends, where you might sleep in a little bit. We all have a tendency to sleep in. That's a little bit has to do with our circadian clock, but in teenagers, this gets exaggerated. So we don't think they're lazy. We think that, in fact, it's a biology-driven process. I'm not an expert on that area, but I'm not aware of any good explanation for why that happens or how it happens. But nonetheless, this impacts things like teenagers not being able to get up to go to school and things like that. Just one last point, just in terms of like touching a little bit on some of the work happening at Michigan and in my laboratory group, is we're actually trying to develop now biomarkers from the blood using genomics and a combination of machine learning to try to identify individuals who have disrupted circadian clocks. That's ongoing research, and it's definitely something I'd like to work with Dr. Burgess on, maybe Dr. Arnett. We can all get together and work on this project. But it's kind of the example of what I hope the kind of things we can do at Michigan.
Fantastic. Would either of the other two experts on the call like to weigh on this?
I mean, I would just say I think jet lag is a great example. When people wonder, well, what does circadian disruption feel like? And I think most of us have had the experience of jet lag. And even there's studies even in healthy individuals in which they run them through a sort of jet lag like protocol in the lab. And yeah, people understandably are saying, I'm just not feeling as good. I don't feel my well-being's lower. I'm not sleeping as well. My mood isn't as good. And so even if there's a pre-existing disorder there, this contribution of circadian disruption, which sometimes is related to the disorder itself, but sometimes it's actually can be exacerbated by some of the behaviors, very understandable behaviors that people engage in. We all do, I think, when we're a little bit sick, we'll retreat to bed, we'll sometimes close the blinds, kind of disappear into our own little world. And unfortunately, that can also induce some circadian disruption as well.
Very interesting. Dr. Arnett, you want to say?
Yeah, I just would add that, in the clinic, we have a whole set of sleep disorders called circadian rhythm sleep-wake disorders. And patients who have these disorders often present to the clinic with complaints that look like insomnia. So the most common thing we see is people come in complaining of difficulties falling asleep at nighttime. But on further examination, what they're really concerned about is the timing of their sleep, when they're able to sleep relative to when they want to be sleeping. So classic example would be somebody comes in and they're not able to fall asleep until 4 a.m. and they want to sleep until 1 or 2 in the afternoon. But of course, they prefer to be sleeping around 11 and getting up at 7, and they may be chronically late for work or missing school. And that's what presents them for treatment. And so sometimes it can be difficult to differentiate these people from people who have insomnia, but you can ferret it out with some specific questions. And really, we think it's important because the origin of that issue relates to the circadian timing system rather than to some other cause. And that's important to know because our treatment strategies are a little bit different for that group of patients, where we might use cues to the circadian system to help effectively realign it with when people want to be sleeping, or at least get them closer to their desired sleep and wake schedule.
That is fascinating. So are those things like light or dark or things like that? Great.
Yeah.
So this is, I'm fascinated already, but we build this as a mental health and sleep talk. So let's get more into the mental health space. And before I do, I want to remind all of our viewers on whatever channel you're watching, if you'd like to ask a question of our panelists, you can enter it into the comments on whatever platform you're watching on, or go to the Michigan Medicine Facebook page and send a direct message if you'd like your comment to be private. And again, we can't give personal advice, and we're not going to be able to answer all the questions, but we will definitely consider them all. So thank you. So now let's go on to, we know that a lot of people in America have depression or anxiety sometime in their life. And then smaller numbers of people, but still significant ones, have things like post-traumatic stress disorder, obsessive compulsive disorder, bipolar disorder, schizophrenia, other diagnoses. What do we know about how common sleep problems like insomnia are in people with these conditions? And do we know anything about why?
Okay, so I can start with that one. So we certainly know that insomnia is much more common among people who have various mental health disorders, really across the spectrum of mental health disorders, compared to those individuals who don't. So for example, in people with depression, there are estimates that as many as 80% of individuals with depression have insomnia, difficulties falling or staying asleep, that causes daytime impairment, and maybe 30% have hypersomnia. That is, they want to sleep too much, they feel sleepy during the daytime. And in people with substance use disorders, which is a particular area of interest of mine, depending on how you measure it, anywhere from a third to 3/4 of individuals have insomnia relative to individuals who don't have substance use disorders. And again, insomnia, we think, plays a key role in the development of mental health disorders. There are several studies, observational, longitudinal studies, that have evaluated people at time 1 and found them to have insomnia, but no other mental health symptoms, follow them up sometime later, 3 years later, many years later in some cases. And there's an increased incidence of people who develop depression, for example, or substance use disorders in those individuals who at baseline had insomnia compared to those who didn't. So it puts people at risk for the development of these. And then in people who have them, we also know that it's more difficult to treat. Insomnia, if you talk to clinicians, is one of the most recalcitrant, difficult to treat symptoms among people who have depression, for example. And even if you can treat them to remission, you still often have often have residual sleep difficulties. And that's important because it puts them at risk for future recurrence or relapse to depression. And in the substance use disorder space, we know that the presence of insomnia in people who are trying to discontinue misuse of alcohol puts them at greater risk for relapse to alcohol misuse. So identifying insomnia and targeting it may be a critical thing to do in order to help people stay well.
That's fascinating. Dr. Burgess.
Yeah, first of all, that makes me think of often what we say in the sleep field, which is sleep is the canary in the coal mine, right? Sleep is so sensitive. It really is one of the first things to reflect that there's potentially other issues going on. In terms of circadian disruption, it's it's similar that yes, circadian disruption is often seen in these mental health disorders. And again, part of it is, I think, driven by the underlying disorder, but also part of it can be the coping behaviors that people engage in. There's also the possibility that there can be differences in sort of circadian mechanisms. So I guess just to give you an example, in the bipolar study we're doing right now, we're examining this idea that potentially people with bipolar disorder are more sensitive to light. And we have a way in which we can measure the sensitivity of the photoreceptor in the eye that sends the light signal then to the circadian clock. And so not only do we want to measure light sensitivity in people with bipolar disorder versus unaffected controls, but then we're going to track people over 2 weeks and look at their sleep and their mood. And our hypothesis is that people that are more sensitive to light may potentially have more variable sleep and mood timing, sleep timing and mood, if their circadian clock is sort of bouncing around a little bit in response to the light. So we'll see. But yeah, it's possible that circadian mechanisms, there's certainly discussion in the literature that circadian mechanisms may also be different in some of these disorders. Because we know there's a genetic component, of course, as well, because in many of these disorders, if your parents, one or both parents had it, you're more likely to develop the disorder.
Dr. Lotta, do you want to expound on any of that, maybe the genetics or other aspects of this?
Yeah, I think so one of the things everyone should be aware of is, and I think it's been addressed in the previous comments to some extent, is there's an association. So you see that these people who have substance use disorders, for example, or some other kind of mental health issue, also don't sleep very well. And so it's always been a bit of a challenge to try to disambiguate cause and effect there. And I think we're getting there also in some of the human clinical studies by following people over time. But also, I would just want to add in the animal model component, that by actually directly doing experimental manipulations to disrupt, for example, the genes that are involved in circadian rhythms, and then you can look at depression-related, for example, behaviors in animal models, I think has really helped to advance our understanding of what the cause and effect relationships are and what the underlying mechanisms might be. And hopefully that can lead back to change, to inform the clinical approach that we might take.
Thank you so much, all of you. And so, we've been talking about these sort of more chaotic sleep schedules or irregular ones. For someone who doesn't have a family history or doesn't have a past diagnosis, I think you touched on this a bit, but can we just go back to that question of, if you over a long period of time are getting too little sleep or don't have a regular sleep schedule, could that raise your risk? And how can you, perhaps use that as more motivation to try and tend to your sleep now versus have a potential risk down the road?
Yeah, so I think, yes, it does increase your risk. Not getting enough sleep, having erratic sleep schedules, they definitely increase your risk. And, sometimes we refer to kind of the pillars of health. So nutrition, exercise, and sleep is definitely one of those pillars. And that's something that we ideally should be paying attention to, on a daily, if not weekly, at least weekly basis, right? We should be thinking about what we're eating for our health. We should be thinking about it, how much we can exercise. I know that's hard as part of our health, but it's the same thing for sleep. We really need to prioritize it if we want to be healthy. And then I guess just to complete this sort of picture for you, if we think of these pillars of health, sometimes we think of the circadian system as sort of the foundation on which these pillars of health are resting. The circadian system, as explained, is regulating our physiology, our brain activity across the 24-hour day. And if we are able to stabilize our sleep timing, help reduce the circadian disruption, everything else will benefit from that.
Yeah, can I just jump in, Kara? Is that okay? Yeah, that's a great point, Helen. I just want to sort of expand on that a little bit and introduce this concept that's been in the sleep field now for probably a little bit more than 10 years called sleep health. Right? And it's important because sleep health is really a multi-dimensional concept. So I think we frequently get caught up in this idea that I need X number of hours of sleep, 8 hours of sleep or 9 hours of sleep. And it's true, duration is important, but there are other facets of sleep health that are important to consider. We've been talking a little bit about the regularity and the circadian timing of it. So regularity is critically important. You know, we've learned that people who have highly irregular sleep schedules, maybe sleep short during the work week and then sleep long on the weekends, that has adverse health implications. More regularity, generally speaking, is better. Duration is important. Efficiency is important, generally speaking. So in efficiency, we usually think of solidness of sleep, how solid sleep is, rather than broken up sleep. So more solid sleep is generally better. And the timing is critically important. We've talked a little bit about that with respect to circadian. So it's important to be sleeping at the right time for your brain. Everybody's rhythm is a little bit different. Some people tend to be more morning people, others are more night owls. And so as far as your sleep habits, it's really best to align your sleep habits to the extent you can with your internal natural rhythm. So all of these facets of sleep and circadian health are critically important to have good sleep health. And I think we often get too caught up in the number of hours of sleep to the exclusion of some of these other critically important factors that contribute to our overall functioning.
Thank you for that. That's a great point. So it's the overall way we approach sleep, not necessarily, I gotta get my 7 hours. So let's talk about some of the things that people might be doing to help them sleep or to stay awake and how those can affect. So let's start with caffeine. So whether it's in pop or coffee or tea or energy drinks or tablets, what does caffeine actually do in the brain to increase wakefulness? And then what are the pitfalls of using it to try and make up for the fact that you got too little sleep?
Wants to go.
Well, I'll leave the specific brain question. Maybe Dr. Alana can comment on that because we understand a little bit about the mechanism. But I guess when I think about caffeine, I'm not sure there's really a lot of good news there, I'm afraid. So, though I always think back to a study that was conducted about 30 years ago, and it was a really simple study. They had healthy young adults in the lab, and they gave them 200 milligrams of caffeine to drink in form of coffee at 7 a.m. in the morning. And then later that night, they put them to bed and they had them all wired up so they could study the brain waves. And they still saw, versus a placebo, a drink without any caffeine, they still saw that the caffeine was impacting sleep. So people were taking longer to fall asleep. There were less slow wave sleep, which is sort of the deep restorative sleep that we get. And in part, this is because caffeine just tends to hang around for quite a long period of time. So I cannot give up my caffeine, just on a personal note. So I'm afraid I have reached the conclusion that my caffeine use in the morning is probably impacting my sleep at night. So I do try and keep my caffeine intake somewhat low. I'm probably only using about 100 milligrams in the morning. I try not to use caffeine in the afternoon, recognizing that that will have an even greater impact on my sleep. And of course, we know there's decaf options out there. So I'm a tea drinker. I love my tea in the morning. It's kind of part of my morning ritual. So I might have my first cup of tea with caffeine in it, but then after that, I'm making the decaf with the idea that I can still enjoy some of that, but without the additional insult of caffeine. And I guess the last thing that comes to mind with caffeine is it's early days, but there's some emerging research suggesting caffeine, particularly in the evening, can actually shift our circadian rhythms or help our circadian rhythms shift a little bit later, which we do not want, similar to the effects of getting too much light after sunset in the evening. So again, not necessarily a lot of benefits of caffeine.
You're making me quit my morning coffee. Just listening to you. I will say, since Helen mentioned it, one of the things I mentioned at the very beginning was this kind of homeostatic regulation of sleep. So the longer you're awake, the stronger your drive to sleep. You pull an all-nighter, you're really tired the next day. And one of the molecules that we think is really important for that is one called adenosine. Adenosine being a breakdown product of like the energy molecule of the brain, ATP. So adenosine is what kind of helps to drive that sleep when we've been awake for too long. Caffeine turns out to be an antagonist that blocks the effects of this adenosine. And that's how it kind of keeps us awake. And what's really interesting is like virtually every culture throughout the world has some kind of beverage, product, food that basically contains some stimulant like caffeine, usually caffeine itself. Whether it's coffee drinking countries, tea drinking countries, you name it. So it seems to be a very common part of human existence, that we want to stay awake. And we have this drive to sleep that we're constantly battling to stay awake. So we do know quite a bit about that, but as Dr. Burgess said, it's may not be a good thing to take a lot of caffeine at least for our sleep quality.
I was just going to say that, as with everything, the dose matters, right? The 1 cup of tea versus the 4 cups of Diet Coke at dinner time, right? So yeah, right. Let's talk about some other substances. Oh, Dr. Arnett, did you want to jump in on caffeine?
I was just going to try and put a little more positive spin on caffeine. So where it does benefit is it does help you stay awake during the daytime, and to the extent that you are sleepy, tired, it can help you temporarily at least overcome that sleepiness. But it is all about, figuring out how to do that without it impacting your nighttime sleep. And I'm impressed that Dr. Burgess mentioned that study, because I was thinking of exactly the same study to talk about. It was a highly impactful study, because these were good sleepers that they took. It gave them caffeine in the morning, and you still see residual effects on EEG at nighttime. So I hear a lot of patients will tell me, I drink caffeine at 9 o'clock and it doesn't impact my sleep. It's like that old commercial, here's your brain on drugs, for those who might remember that. We can tell via EEG when you've maybe had caffeine too close to your bedtime, because it will leave a signature in EEG, but it does help you stay awake during the nighttime, and it can improve alertness, it can improve performance temporarily.
During the day,
So it does
yeah.
have its daytime benefits.
Okay, great. Now let's talk about a substance with pretty much the opposite effect, I think, alcohol. So for those people who do choose to drink alcohol, what is the role of it in getting to sleep, staying asleep? Could cutting back on your drinking help someone who's having insomnia? And for right now, let's talk about more folks who are using alcohol without having a dependence or a problem sort of drinking. We'll get to that topic later. So maybe Dr. Arnett, do you want to start on that as well, and others can jump in?
Sure. Well, I can't put as a positive spin on alcohol for sleep as I maybe can for caffeine. So alcohol is a CNS central nervous system depressant. It can help you fall asleep. It can hasten the onset to sleep if it's taken close to bedtime. And it can temporarily increase deep sleep, some of that deep restorative sleep that's important to our functioning. But alcohol is eliminated from our system relatively rapidly. And so about halfway through the night, it can really disrupt sleep. And the second half of the night typically is characterized by increased fragmentation of sleep, frank awakenings, maybe having to get up to go to the bathroom. And at the end of the night, generally speaking, sleep is of a poor quality. People don't feel refreshed. And it's generally not a good thing for sleep. So for people who use alcohol in a moderate way, but regularly, and if they find they're having disrupted sleep, it would make sense to cut back on alcohol and see its impact on sleep. You need to do this more than 1 day or 2 days. You'd need to do this over a period of time in order to have an understanding of what impact it's having. But I'd also hasten to add that for people who have persistent difficulties with sleep, it's rarely one thing that's contributing to the sleep disruption. So while reducing alcohol might be a low-hanging fruit and something to try, if you're having persistent difficulties with sleep, it's really important to talk to your doctor to make sure you get a full assessment of what's going on with your sleep, and to be sure that you're getting the right information.
Yeah, I was just going to add that I think it's great we're talking about alcohol, because we know it's the #1 sleep aid that people are actually using. So, and I was just going to throw in also that alcohol can disrupt the circadian system as well. And we did some work again looking at the sensitivity of those circadian photoreceptors in the eye that send the light signal. And this was in quite heavy drinkers. So these people were otherwise healthy, but drinking probably on average around 20 drinks a week, so on the heavier side. And we did find that the alcohol compared to light drinkers was suppressing their sensitivity to light. I think this is an area that will be interesting to explore, all of these sort of substances that we're all using on often a daily basis, how that actually impacts how our brains even process the incoming light signal.
Fascinating. Dr. Lotta, anything to add on the alcohol question?
You're going to make me stop drinking alcohol. No, I'm just kidding.
This is turning into the no fun live stream. Uh-oh.
I concur with what my colleagues have said here.
Great, thank you. All right, well, let's get into a third substance, which might be the second most common thing that people are using to try and sleep, which is cannabis, and products that contain CBD or THC, and especially with legalization in many states. Dr. Arnett, I know you've studied this actually, and so what do we know and not know about these components of cannabis and their impact on sleep?
What we don't know is a lot more than what we know. So this is an area where certainly the hype is outpacing the science. And there are really very few well-conducted research studies to draw firm conclusions on about the effects of these substances. But it's in widespread use for certain. And, I've made it a habit when seeing everybody to ask them explicitly if they're using cannabis. We used to just ask about, recreational drugs in general as it pertains to sleep, but now we ask specifically about cannabis. We did a study a few years ago looking at people who were seeking medical cannabis cards. And we polled about 800 of them, and 80% of them said that they used cannabis for sleep specifically. So it certainly is in widespread use, but the amount of information we have on it is minimal. Many of the early studies, experimental studies, were conducted like in the 60s and the 70s. And the general conclusion is that low levels, so there are a variety of different cannabinoids in cannabis. The two most widely studied, as you kind of alluded to, Kara, are THC and CBD. Some of the early studies suggested that low-dose THC may acutely or in short term actually improve sleep to some degree, increase slow-wave sleep, and be somewhat beneficial for sleep acutely or transiently. But with repeated use of cannabis over time, certainly tolerance develops, and that's sort of across the board with most substances. So with repeated use of cannabis and THC and CBD in general, we see a tolerance to the sleep sedating effects of those substances, as well as the sleep architecture effects. Sleep becomes more disrupted. People have more difficulty falling asleep. And a very consistent finding is that in regular cannabis users, if they withdraw from cannabis or reduce their use of cannabis, one of the most common symptoms of withdrawal is increase in insomnia, more difficulty sleeping. And we think that might be one of the reasons why people are maintaining their cannabis use, in part because they're sort of self-medicating their sleep difficulties. In terms of insomnia, there have only been 3 studies that I'm aware of, controlled studies that have looked at cannabis for insomnia, for people with chronic insomnia. And those studies have found that the supplements or the synthetic pills that included THC had a small to moderate effect on subjective insomnia symptoms over the course of 4 to 6 weeks. No differences in terms of objective measures, like if we bring people in and do a sleep study, no real differences, but much more work to be done. It's also been studied in obstructive sleep apnea and other sleep disorders with generally small effects overall. So there's a lot of unanswered questions and a lot more research needs to be done. It may have value at some level, but we really need a lot more research on the topic before we can really understand it better.
Thank you so much. Would either of the other panelists like to comment on this? That was really a great answer. And I think there's some movement to change the ability to do research on cannabis and have more studies be done. So watch this space, I think, as well. We're getting some great audience questions. I wanted to add one in that relates to our caffeine discussion, which is somebody was asking about different types of beverages that might contain caffeine. Is one a better choice than another versus, green tea versus an energy drink? Does this mainly get into the doses? The molecule's the same, right?
Yeah, I'm not really an expert on all the other molecules that are present in these beverages, but I could imagine that maybe there are other substances in green tea that are considered beneficial. But apart from what else might be in the drink, my understanding is that caffeine is pretty much caffeine. That molecule is
Right.
set.
And the energy drinks sometimes have, what is it, taurine in them?
Yeah, I think I caught a headline that it was Panera, right? Who had that high energy drink they were selling, and there were a lot of side effects, and they're pulling that now from their line, which I think is a good thing. These drinks, I think, are kind of over the top, right? We don't need to go that high in our levels, caffeine.
I just would add, it is good to know how many milligrams of caffeine you're consuming in some of these beverages, because some of them can be deceptively high. They may have much more caffeine than you knew about. So it's important to know how much you're intaking.
Yeah, that's a
Excellent.
good point. I've seen a health recommendation that really we should be, I mean, to me it seems still somewhat high, but ideally we're consuming less than 300 milligrams a day. And definitely there are some beverages you can buy over the counter that are in excess of that very easily. So I think Todd raises a great point that we should be keeping an eye on just how much caffeine we are consuming.
Excellent. Thank you. We also had an audience question, and I think this relates to this idea of the mind-body connection of when you're trying to get to sleep, but your mind keeps racing. You have things that you're thinking about, things that you are on your to-do list, things that you're worried about, or did I do the right thing today? Could I give you a comment on sort of how can you address that? Are there tactics and tips that you could advise people?
Yeah, so it's probably the most common thing we hear in people who have insomnia. The source of the problem with insomnia is that they can't fall asleep, or they wake up and can't fall back to sleep because they're worried, or they're thinking about what they've got to do the next day. And so that's one of the most common things we hear. And there are a variety of different things you can do. So we will often institute some behavioral strategies. One of the strategies within cognitive behavioral therapy for insomnia is effectively to leverage what Dr. Alada referred to before as our homeostatic system. Sometimes we think of it colloquially as our sleep drive system, to basically make people sleepier. And so if you're sleepier when you go to bed, there's less of a chance that you're going to maintain wakefulness because you're worried, because that sleepiness will override that worry and that concern, that arousal that you might get from your brain. But there are also strategies to directly combat what you're thinking about. First of all, it's about breaking down what is going on. For people who are running through their mind what they've got to do the next day, sometimes setting time aside before they go to bed, the last hour or so before they go to bed, developing a routine where you're actually mapping out your next day before you go to bed, so that you do that ahead of time. That can help prevent that rumination or worry in the context of trying to sleep. And then when people are worried about things, there are other strategies. There's a strategy called worry exposure, where you actually try to take the worry outside of the nighttime and set aside time far away from bedtime. You would want to do this before bed, so several hours before bedtime. And you would want to set aside a time, maybe 30 minutes, and you would set an alarm 30 minutes or so, no more than 45 minutes, where you're actually trying to work through the worries. The idea is that worry is, it has its place because it's a signal that there's something that you need to pay attention to, but it's generally speaking an unproductive activity. So you take worry that's unproductive at nighttime and you institute it during the daytime, where you can try to problem solve the worry that's occurring to you. So you might set 30 minutes aside in a day to try to problem solve the specific worry that you're having. And then when it encroaches at nighttime, as it may do, you try to train yourself to say, I've got time set aside the next day to worry, to think about that further. And you get into a habit of having this regular worry exposure exercise in your routine that can help to mitigate the worry at nighttime. So those are a couple of strategies that can be used that can help to manage those cognitions that can be intrusive at nighttime.
Dr. Arnett, I want to move myself a little bit into the audience here a little bit. I want to sort of punctuate one of the things you said at the beginning, because I think it's might be counterintuitive and maybe you can clarify or deepen this explanation. And as you were talking about the homeostat or the drive to sleep, but it's almost counterintuitive that you might recommend to someone who's having trouble sleeping, you might tell them to stay awake a little bit longer. So I just want to just sort of punctuate that point, and maybe you can, I don't know, I don't want people to do something like totally crazy, but maybe you can just clarify or add to that point. I thought it was really
Yeah,
interesting.
that's a great point, Dr. Lana. Thanks for bringing that up. And I don't want to get too far into the mechanics of the strategies, but the principal idea is that when people have difficulty sleeping at nighttime, the reflexive response is to basically spend more time in bed to get more sleep. Makes a lot of sense. We're pursuing, I only got 5 hours of sleep. I need 7 hours of sleep. So I'm gonna spend longer in bed to try to get more hours of sleep. And in fact, that's a counterproductive activity. It might work every so often, but it's not something that works regularly. In CBT for insomnia, we effectively turn that on its head and we leverage the homeostatic or the sleep drive system. And we tell people, well, if you're averaging only about 5 or 6 hours of sleep, that's really about as much as you should be spending in bed to start. It's not an end point, but it's a start point to try to make, instead of pursuing number of hours of sleep, you pursue efficiency of sleep. You try to fill as much of your time with sleep as you can. Once your sleep is more efficient, then you can start to increasingly spend a little bit more time in bed in a gradual way until you're getting a sufficient number of hours that's of a good quality at the right time in your brain so that your functioning during the day is optimized. And that's a technique that we use frequently. It's very effective. It's also really hard to do in practice, and I wouldn't recommend somebody just try that on their own, but it is something we found to be very effective for improving quality of sleep. And also, as I said, it can be a way to mitigate some of those intrusive cognitions at nighttime.
Yeah, I was just going to add, I was thinking about the fact that there is a circadian rhythm in mood. And interestingly, we tend to have the worst mood and potentially the worst outlook on things at around 3 or 4 in the morning. So when you wake up and you start worrying about things, that old adage of things will look better in the morning is actually very true. Things will look their absolute worst when you're worrying about them at 3 or 4 in the morning. So, yeah, when that happens to me, I always remind myself, look, you're not necessarily thinking the most rationally at this point in time. Defer it to the morning, and of course, it really does look better in the morning.
So you're really talking about an actual mood cycle,
Yes,
circadian
there's been
rhythm.
lab studies
Fascinating.
where they've assessed healthy people in the lab, and sure enough, mood is at its worst around 3 or 4 in the morning.
Fascinating. Thank you. All right, we're running low on time. So let's talk about the elephant in the room, which is smartphones. We had an audience question about blue light versus warm light and different types of light from a smartphone or other device, or maybe also some of these sleep regulating lights, these morning light devices that people have. But let's start with smartphones. What have they done to our sleep patterns, and how can people try and undo some of that damage? And especially if someone's also dealing with depression or anxiety or things like that. Who would like to tackle the smartphone?
I'll start with the light part of it, and others may also address light, but maybe also discuss the content of what is on the smartphone and impact on mental health. But that's not my expertise. For as light, it's super interesting science, actually. The discovery of like unique cells in our eyes that actually sense the intensity of light that you experience during the day. And I think Dr. Burgess sort of alluded to this a little bit in her presentation. Like when the sun sets, the light goes away, and that sort of sets our part of the light cycle that sets our circadian clock. So when you are looking at your phone, and I should add, these photoreceptors that were found in your eye are very sensitive to blue light, to the wavelength blue, and much less sensitive to red wavelengths of light. So when you are looking at your phone, staring at your phone for hours in the evening when it's normally dark outside, your body says, it's still daytime. I should stay awake. And your circadian clock actually shifts. So it's delayed. So it doesn't allow you to fall asleep until later in the day. So essentially it's keeping you awake in many ways, but one of the ways is by shifting your circadian clock. So one of the ways you can address that particular issue is like many of the devices now have a mode, a night mode or evening mode, or forget what I'm not endorsing Apple products, but Apple, I forget what theirs is called. But basically it shifts the wavelengths to that more into the red spectrum. And so the impact on your on that circadian or sleep cycle is going to be much less doing it that way. And so that, that's definitely something one can do to address that issue.
Yeah, I think the point about the content of what's on the phone is a really good one. And anything that perhaps is, I would say checking the news right before going to bed is probably not, the best idea. The other thing about smartphones is we tend to hold them pretty close to our eyes. So sometimes people will ask me, well, what about blue wavelengths from a TV? And I'll say, well, if the TV's across the room, that's going to be less intense. Whereas, if you're watching something or reading something on your phone, you do tend to hold it quite close to the eyes.
That's a
Yeah,
great
although
point.
TVs
Yeah.
are getting bigger and bigger, so I don't know how much
That's
longer we'll be able to say that.
true.
An 80, 90-inch TV, and that's
Yeah,
how much it's increasing. But that's, I mean, in the clinical context, it's something we always look for. And for people who are having trouble sleeping, certainly try to strategize around ways that they can put their phone away in advance of going to bed. I mean, setting a window of time before bedtime when they're in dim light conditions. It's not including looking at their phone because of the point Dr. Burgess made, and they're engaging in a quiet activity. Those old books we used to have, or had paper books, and we used to look at. Maybe we do something like that, not on their phone, and not look at it during the nighttime if they're awake. So those are, again, it's not usually one thing, but that's an important contributor to disrupted sleep, and so it's something that we always address.
that's great. Thank you so much. Before we get too close to the end, I think we need to talk about melatonin because it's another thing that people are using to try and sleep. Dr. Burgess, you want to address melatonin? What kind of evidence is there? What is it? That kind of thing.
Yeah, so I guess first of all, we're probably all familiar that our brains actually make melatonin, produce melatonin. And melatonin is a really important signal that comes from the circadian clock. So as mentioned, we have this circadian clock in our brain, and usually about 2 hours before we go to bed at nighttime, it determines that sunset has happened, so the sun's gone down, and the clock is saying, okay, it's now nighttime. And it signals the pineal gland to start secreting melatonin. And melatonin travels all the way through the body and is a really one of several important signals that is really sending that message to the rest of the body. Okay, it's the start of what we call the biological night. It's time to now prepare for this particular phase in the day. Melatonin supplements, they can be beneficial. It's well accepted that melatonin in the dose of around 3 to 5 milligrams, if you take it about half an hour before you want to fall asleep, it will help you fall asleep more quickly. After that, it doesn't necessarily do a whole lot. There's mixed evidence, particularly if you're taking a more extended release formulation of melatonin, that maybe some studies have found that it can reduce awakenings during the night. But really, the well accepted effect of melatonin is that it will help you fall asleep more quickly.
Thank you. And Dr. Alada, I can't help but ask, do fruit flies in your lab have melatonin as well?
Strangely, it's not clear. Not been well described. Strangely, they have some of the enzymes to produce it, but I'm not familiar with anyone ever. We've tried to feed them melatonin, but that's a whole separate
Oh, that sounds
story.
fascinating. That's a whole other.
I did want to add a little bit to what Dr. Burgess says. Maybe Dr. Arnett can maybe address this as well, which is that some of the melatonin you buy off the shelf, there's been a lot of questions about what the actual content of melatonin is. So it's not FDA regulated, and so because of that, the actual contents of the melatonin can be quite variable in what you purchase off in the drugstore as melatonin. So that's something to be really careful about. There's some formulations that are a little bit more well characterized, and so just kind of paying attention to that might be important.
Thank you
Yeah,
so much.
I would agree. And some of the supplements, not just melatonin, but all supplements, the bottles will have a USP stamp on them. And what that means is that company basically signed up to have someone independently assess the content and the sort of purity and also the dose accuracy. So those brands would tend to be recommended over others. I think that's a really good point.
That's a really important point. Thank you. We've had a couple of audience questions about CBTI or CBT, cognitive behavioral therapy for insomnia. So Dr. Arnett, I know we can't endorse specific online services or give any specific advice, but if someone's interested in exploring this, how can they find, and do they need to get a sleep study in a lab where they get all the wires on their head and tell whether they have a biological thing like apnea, or is it okay to start a CBTI course, whether or not you've had a sleep study?
That's a great question. So I think you need to start by having a thorough assessment. So in general, insomnia does not require sleep studies unless we have a suspicion that somebody has obstructive sleep apnea, in which case, and there's a high percentage of people who have both insomnia and obstructive sleep apnea. And so, for example, we run a clinic that's a multidisciplinary clinic where people come with complaints of insomnia. We do a thorough evaluation, and we send more than 50% of those individuals who come in with complaints of insomnia for sleep studies because we have concerns that we have a high suspicion that they've got sleep apnea that's contributing to their insomnia in some way. So I would start with a full assessment through your doctor. But to the extent that that's not that obstructive sleep apnea or another sleep disorder is not playing a role, then CBT for insomnia may be beneficial. And there are some online. You can look at the the National Sleep Foundation is a good resource for finding out more about CBT for insomnia. There are some apps that are available that are free and can be used free of charge. One in particular, CBTI Coach, is one that we use frequently with our patients in combination with them coming to see us as a therapist. Insomnia Coach is another one that was developed by the VA, actually the VA. And so it's an evidence-based, and that's a standalone app that can be used. They're both free of charge and contain the same elements of CBTI that we generally endorse.
Fantastic. All right, we're really down to the end here. Before we let you all go, I would love to hear more about research that you're hoping that people can join, or other research that we still need to do at U of M, and then I'll just close it out after that. So each one of you take a moment. Dr. Lada, would you like to start?
I just wanted to use the opportunity to kind of give a little plug for the Michigan Neuroscience Institute, which I've joined about 7 months ago and leading the Institute now. And I just really want to talk about the mission of the Institute. I think it's a very exciting time for neuroscience research at Michigan. And really the goal of the Institute is really to bring together all of the neuroscientists across campus, really to catalyze interdisciplinary neuroscience research and really to ultimately solve the mysteries of the brain, like why do we sleep? And then use that information to help prevent disease and really to promote health. And I think sleep is almost near at the top of that list in terms of the kinds of questions. And many of the people on this Zoom call are part of the community of sleep scientists and clinicians who are really going to make a major impact in this area. So I just want to emphasize that Michigan is really at the forefront of this.
Dr. Burgess.
Well, yes, I just wanted to thank you, Cara, and everyone else at Michigan Medicine that have sort of enabled this discussion to happen today. As I think we've mentioned, sleep and circadian rhythms are so important to health, and I think raising awareness of this, and in our research, we're hoping to test different things that people really are not complicated, ideally non-drug treatments that people are sometimes more open to, and things that people can really implement in their own homes. So yeah, that's what we're hoping to continue to do. But thank you
How
for
would
the
someone join one
opportunity.
of your studies?
Well, many of us are disorder-based, and so, but I should mention the University of Michigan has a research registry that I think has over 70,000 people registered now. If you're interested in participating in research, whether or not you have a disorder or not, you can sign up, create a little profile, and you will receive emails relating to all of the different possible research studies that you could participate in. And Thank you also to all of our research participants who,
Yeah, and
without
actually,
them, we would not be able to do any of the research that we do.
absolutely. And I happen to be in that registry myself. And you
Oh,
can go
great.
to umhealthresearch.org to join that registry so that people like Dr. Burgess can contact you when they have a study that needs people like you, whether or not you have a condition, or you might be somebody who could be a comparison to the people who have that condition, right? Dr. Arnett, any parting thoughts?
I just would say thank you to Kara, to you, and to those who have joined us, and also indicate that we have a couple of ongoing studies as part of our sleep and circadian research lab that are one for people who have alcohol use disorder, and another for people who regularly use cannabis. And we're looking at non-drug treatments and their impact on people's sleep and substance use. And those can be found at umhealthresearch.org if people are
Perfect.
interested in participating. And thank you for hosting today, and thanks everybody for joining us.
Great. Well, thank you everyone for joining us. And I wanted to make sure that folks know that if you've been watching and you want to give us feedback or join our email list for mental health topics, if you want to go to mishmed.org/M news, that's mental health news, and we'll get you signed up for our email list, and you can stay on top of mental health news and research from U of M. And we really do hope you'll share this video with others. And thank you for joining us. Thanks to the Alumni Association for helping support, and have a good day.